Picture this. You're standing on an entirely different world, completely unlike our own. You look out toward the horizon, expecting to see a familiar landscape, maybe some rolling hills or calm sea. But instead, you're met with an environment so hostile, so utterly alien, that it literally challenges our basic definition of what a planet can even be. So you can definitely leave your umbrella at home for this one. Today, in this cinematic explainer, we're taking a premium journey deep into the cosmos to explore a world that totally pushes the boundaries of physics and planetary science. I want you to just shatter your normal Earthbound expectations for a second. What if I told you that rock could literally rain from the sky? Sounds crazy, right? On Earth, we're totally used to looking up and seeing clouds full of water. We all know the gentle rhythm of a rainstorm. But out there, in the vast expanse of the universe, there's a place where the atmosphere itself might actually be made of vaporized rock. A place where getting caught in a thunderstorm would mean something unimaginably terrifying. Well, let's dive right in. Welcome to K2-141b. We're talking about a rocky exoplanet located hundreds of light years away from us. When astronomers say exoplanets, they just mean planets that orbit stars outside of our own solar system. And let me tell you, K2-141b is one of the most extreme, absolutely fascinating rocky worlds we have ever found. Its defining characteristic? It orbits shockingly close to its host star. I mean, much, much closer than Earth is to the sun. To really wrap your head around just how tight this orbit is, consider this: a fraction of an Earth day. That is literally all it takes for K2-141b to complete one single orbit around its star. We're talking a matter of hours. On Earth, we wait 365 days to celebrate a new year. On this exoplanet, a whole year passes before you've even finished your shift at work. And this incredibly tight orbit creates a brutal, punishing environment that dominates absolutely everything about the planet. Because K2-141b is basically hugging its host star, gravitational forces have left it completely tidally locked. What this means is that one side of the planet permanently faces the star in an endless, scorching day. The star never rises, it never sets, it just hangs there in the sky, completely blasting the surface. Meanwhile, the opposite side faces away, trapped in this permanent, freezing, eternal darkness. It is literally a world split right down the middle. Let's zoom in on that dayside for a second. Because it's relentlessly bombarded by just massive amounts of stellar radiation, the heat is entirely beyond human comprehension. Scientists estimate that temperatures on that star-facing side reach thousands of degrees. And we're not just talking hot enough to melt metal. It's an unrelenting planetary furnace, hot enough to do something that sounds absolutely impossible to us here on Earth. It can melt solid rock. Here on Earth, we're super lucky to have deep, beautiful oceans of liquid water and solid mountains of granite. But on K2-141b, well, if you were to take Earth's mountains and heat them up until they turned into liquid, that's exactly what you'd get. Under these extreme conditions, scientists actually believe the surface is covered in vast, unimaginably deep oceans of molten lava. It's a gorgeous ocean seascape, sure, but it's made entirely of liquid fire. Okay, so we've got a planet-wide ocean of magma. But let's hit pause for a second and ask, what on Earth, or what on K2-141b, I should say, is happening above that lava? As terrifying as a liquid rock ocean is, it's actually not even the strangest part of this planet. To understand what makes this world truly bizarre, we need to look up from that glowing surface and figure out what is going on in the sky directly above this massive planetary furnace. You see, basic physics tells us that if you crank the temperature high enough, a material doesn't just stop at melting from a solid to a liquid. It undergoes a whole other phase change. At thousands of degrees, components of that molten rock actually vaporize. They literally turn into gas. This means K2-141b is acting like this giant geological experiment, potentially boasting an atmosphere filled with vaporized rock. The very ground it's made of is just evaporating right into the sky. Just compare that to what we're used to. Earth's weather is, frankly, pretty comfortable. Our atmosphere is mostly nitrogen and oxygen. We've got fluffy water vapor clouds, and we get rain. But K2-141b's weather system is wildly hostile. Its atmosphere is this thick, swirling soup of vaporized minerals. It's a totally alien chemistry that transforms the entire sky into an aggressive, superheated chemical haze. Let's map out this planetary weather system, following the flow from the furnace straight into the deep freeze. To understand how this builds into an actual weather system, we've got to follow the flow of this vapor across the terminator line. That's the border between day and night. Because when you have extreme heat on one side and extreme cold on the other, you get dynamic, insanely powerful atmospheric circulation. Here's how scientists model this mind-blowing cycle. Step 1. The rock vaporizes off those boiling lava oceans on the dayside. Step 2. Powerful supersonic winds, driven by that massive temperature gap, carry the rock vapors straight toward the night side. Step 3. As it hits the darkness, the temperature just plummets, causing that mineral vapor to rapidly condense back into a liquid or even a solid state. And finally, Step 4. This solid material falls right back down to the surface. This, my friends, is the cycle of rock rain. It evaporates, blows across the planet, and rains solid rock down into the freezing darkness. Pretty incredible, right?
Now, we really need to talk about science versus sci-fi and distinguish our scientific models from direct observations.
Because as spectacular as rock rain sounds, it is absolutely crucial to distinguish between what we have physically seen with our own eyes and what scientific models predict should be happening based on the laws of physics. We always need a rigorous reality check. And the big takeaway here is this. Astronomers have not watched rocks literally raining on K2-141b. We haven't set a probe out there to record an HD video of a rock storm. This entire weather cycle is a highly educated, meticulously calculated scientific model. It's based on the planet's estimated conditions, stuff like its mass, its distance from its star, and the stellar radiation it gets blasted with. The real atmosphere is just too far away and too difficult to observe directly with that kind of visual clarity right now.
So you're probably wondering, how do scientists actually know any of this if they can't just snap a picture? Well, it is the ultimate cosmic detective work. They take deep observations of the star system itself. They apply advanced principles of physics and thermodynamics to figure out exactly how materials behave at extreme temperatures. They run incredibly complex atmospheric models on supercomputers, and they use precise orbital measurements to gauge the planet's exact proximity to its star. By putting all these pieces of the puzzle together, they can confidently estimate these wild conditions. And because of those brutal conditions, we can confidently make one very definitive statement. The environment on K2-141b is way beyond anything known to support Earth-like surface life. So no, there are no sci-fi creatures swimming around in the lava oceans or flying through the rock vapor storms. It is a completely uninhabitable, deadly environment. But hey, just because it's lifeless certainly doesn't mean it's worthless.
Which brings us to a huge question. Why study extreme worlds to unlock the secrets of the cosmos? Seriously, if we can't live there and nothing else can either, why do astronomers spend so much time and money looking at a place hundreds of light years away? What's the point for us? Well, it's because these extreme planets act as natural physical laboratories. We literally cannot recreate these scales of heat and pressure perfectly here on Earth. K2-141b allows scientists to test how rocks and minerals behave under literal planetary extremes. It gives us vital clues about how atmospheres form in the first place, how they evolve over time, and how they can eventually be destroyed. It pushes the known limits of physics, giving us a much wider understanding of planetary evolution across the entire universe, which, believe it or not, actually helps us better understand the history of our very own solar system. You know, the universe is just vastly more creative than we usually give it credit for. It doesn't only give us comfortable Earth-like worlds with blue skies and liquid water. It provides frozen spheres, dead star orbits, and scorching furnaces like K2-141b. It constantly forces us to rethink what a planet can even be. It's a profound reminder that the cosmos is boundless, totally mysterious, and just relentlessly fascinating. So as we wrap up our journey to this wild world of lava oceans and rock rain, it really leaves you wondering what other impossible worlds are hiding out there in the dark. If you could safely visit K2-141b for 1 hour, would you go? Tell us your choice in the comments, and subscribe to Curious Orbit for more space science and cosmic mysteries.